Hi everyone! In the previous videos you learned how to build charts, which is the first step in approaching your data. The second step is checking for assumptions. Why assumptions are important? I took a part from Andy Field's Discovering Statistics with SPSS book, which using an everyday example shows why assumptions are important. There are good reasons for taking assumptions seriously. Imagine that I go over to a friend's house, the lights are on, and it's obvious that someone is at home. I ring the doorbell and no one answers. From that experience, I conclude that my friend hates me and that I am a terrible, unlovable person. How tenable is this conclusion? Well, there is a reality that I am trying to tap, that is, whether my friend likes or hates me, and I have collected data about that reality. I've gone to his house, seen that he is at home, rang the doorbell, and got no response. Imagine that in reality my friend likes me. He never was a good judge of character. In this scenario, my conclusion is false. Why have my data led me to the wrong conclusion? The answer is simple. I had assumed that my friend's doorbell was working, and under this assumption, the conclusion that I made from my data was accurate. My friend heard the bell but chose to ignore it because he hates me. However, this assumption was not true. His doorbell was not working, which is why he didn't answer the door. And as a consequence, the conclusion I drew about reality was completely false. So, when assumptions are broken, we stop being able to draw accurate conclusions about reality. And in scientific research, it has serious consequences. Many statistical tests that we use are parametric tests. And in order to use parametric tests, you have to check for assumptions whether your data is parametric or not. If not, then you have to use non-parametric tests if there's any, because not all the parametric tests have an alternative, a non-parametric alternative. So if you use a parametric test when your data are not parametric, then the results are likely to be inaccurate. Therefore, it is very important that you check the assumptions before deciding which statistical test is appropriate. There are 4 assumptions for parametric data. The first assumption is your data should be normally distributed. There are several ways of checking it. You can do it visually or you can quantify normal distribution. I suggest you to do both to have a real picture. You've already encountered one way of checking for normal distribution is building a histogram. The second is homogeneity of variance, which will be the topic of the next video. Interval data, you can judge this by looking at your data, whether it was measured on an interval scale like reaction times, scores on a test, etc. And independence. Independence depends on how your data was collected. If you compare different groups, then it means that the behavior of one participant shouldn't influence the other, for example. Okay, so in this video, we will check for normal distribution. First visually, then we will try to quantify it based on a data set that we already used. Remember the Download Festival dataset. It's in the Google Classroom, but also it can be downloaded from the link below the video. So remember that in this study, a scientist went to a festival and wanted to see what happens with the hygiene level of concert goers. So on 3 consecutive days, the scientists measured the hygiene level of concert goers. There are missing data on day 2 and day 3 because it was very difficult to track the participants down. Also, remember that in the row 611, there was a mistake. One of the participants put 20 instead of 2. So before doing anything with the data, please correct the mistake, and this box should be displayed should display 2.02. So the first way of checking normal distribution is visualizing it. So you can do it by remember the graph builder. So you go to the chart builder and you do it by a simple histogram. So the hygiene level goes to the x-axis, and then here you can see the distribution of your data, which seems to be normal. Another way of looking at it is go to Analyze Descriptive Statistics Frequencies, where you have all the variables displayed in this box. So you can choose the 3 hygiene days. With the help of the arrow, the highlighted variables get into the variables box, and clicking on charts, you can choose histogram, and you also want to see whether your histogram follows a normal curve. So show normal curve on histogram. You continue and you click OK, and then here in the output you will see the 3 histograms. So as you could already see from the chart builder, your histogram more or less follows a normal curve, which seems to be normal distribution. On the second day, your data set doesn't really follow a normal distribution, but the data are piled up on the left side of the histogram, which means that the data is quite on the negative side, so the hygiene of the participants decreased, and it will be shown by the value of the skewness, which tells something about the shape of your histogram. And on the third day, the distribution is again doesn't follow the normal curve. Another way of visualizing the distribution is looking at the p-plots, which is the probability plot. This graph plots the cumulative probability of a variable against the cumulative probability of a particular distribution. So if values fall on the diagonal of the plot, then the variable is normally distributed, but deviations from the diagonal shows deviations from normality. So you go to descriptive statistics, p-plots, and again you will have your variables here. You highlight them with the help of the arrows, you drag them to the variable box, and everything is set automatically. So you click on OK, and you can see that on the first day the data follows the diagonal line, which coincides with the histogram. This is normal distribution. On the second day you can see deviations from this diagonal line, so the data is not normally distributed, and you can say the same pattern here. On the third day there are deviations from the diagonal line. So this is how to look at normal distribution visually, which is important to do as a first step, because you will have an impression about the distribution of your data. It's more telling than a number. As I said, a second way of looking at normal distribution is quantifying it. So for this, you will look at the values of the skewness and kurtosis. The skewness and kurtosis tells you something about the shape of your histogram. Remember that it can be positively skewed or negatively skewed. This one is positively skewed because the tail of the histogram is on the positive side. If it would be on the negative side, the tail, then it's negatively skewed. It can be pointy and flat as well. So this is about the kurtosis. This is, for example, a pointy histogram, but it could also be flat. Okay, so in order to quantify, we go to the frequencies again, statistics, and we look at the descriptive statistical data with a special emphasis on skewness and kurtosis. I don't think we need any charts anymore. Okay, here you are. You can see the descriptive data of day 1, day 2, and day 3. As you can see, the mean hygiene level decreased by the day. You can see the median, the mode, the standard deviation. The skewness on the first day is very close to 0, as well as the kurtosis, which is minus 0.4, which is, and in normal distribution, both the kurtosis and the skewness has to be 0 or close to 0. So this data shows normal or close to normal distribution. Second, if you look at the second day, the skewness is bigger than 1 and the kurtosis is close to 1 as well on day 3. So it already shows that the data is not normally distributed on day 2 and day 3. Let's look at another data set, because I can imagine you get sick of this festival data. So for this, we open a new data set, which is the SPSS exam. And we will see how to do quantifying normal distributions when we compare different groups. Okay, so what you can see here is 4 dependent variables and 1 independent variable. So in 2 universities, Dunstone University and Sussex University, students were taking an exam on SPSS, and here in the first column you can see their results. Here in the second one you can see their scores on computer literacy. Third variable is the percentage of lectures they attended, and the fourth is their abilities in numeracy, which was measured on a scale from 0 to 15. First, let's look at the descriptives for the whole group. So we highlight the dependent variables, put it to the variables box, and we check the descriptives. Special emphasis on skewness and kurtosis. And we might also want to have a look at the histograms. Okay. So the first column is percentage on SPSS exam. Here you can see the mean, computer literacy, percentage of lectures attended, on average 59, 60% of the lectures were attended by the students. And you can see the skewness and kurtosis. The skewness is minus 0.1, which is quite close to 0, while the kurtosis is quite small, it's less than minus 1. But because here we would like to compare 2 different groups two universities, the students of two universities, it is better to look at the descriptives of these two universities separately. So for this, I'll show you how to split your data. You have to go to data, you go to split file, organize output by groups, and the groups based on university. Okay, so here you have the message sort cases by uni, split file separate by uni. Now you can run the same analysis. Descriptive statistics frequencies, we have everything checked from the previous session, and then you click OK. So you can see that for Dunstone University and Sussex University, you have the data set separately. Let's look at the Dunstone. First, here you have the content, actually the content of your analysis. So at Dunstone University, the mean result was 40, while Sussex University, the mean result was 76. So by far, students at Sussex University were, much better. And as for the skewness and kurtosis, Dunstone University 0.3, kurtosis minus 0.5. Both of them are less than 1, which suggests that it might be a normal distribution. But if you look at the numeracy, it's a bit higher. Okay, and at Sussex University, kurtosis, skewness, numeracy. So we cannot say it for sure. Well, we can also look at the histograms, but still, we cannot. It's not a real number that reflects distribution. But there is one way which helps you to say more or less sure whether your data is normally distributed. For that, you use a Kolmogorov-Smirnov and Shapiro-Wilk test. For that, you go to Descriptive Statistics, Explore, and let's say we are interested in the percentage on SPSS exam and numeracy. So you go to the plots, and you would like to see normality plots with tests. We don't need the stem and leaf. Continue. Let's see. Here again you can see the means for the whole group and test of normality. So the Kolmogorov-Smirnov is more often used than the Shapiro-Wilk because the Shapiro-Wilk is more sensitive to very small deviations, which is a problem with big data sets. So we better look at the Kolmogorov-Smirnov results, and this is the significance level. So this significance level should be bigger than 0.05, which in statistics 0.05. So if it is bigger than 0.05, it doesn't deviate from normal distribution. It doesn't violate the assumption of normal distribution. So if you look at the percentage of on SPSS exam, it is bigger than 0.05, which shows that it's normally distributed. While numeracy shows that it's smaller than 0.05, which means it violates the assumption of normal distributions. the cuckoo plot is quite similar to the PP plot. So here is the plot of percentage on SPSS exam. Yeah. And for the numeracy, so you can see that it deviates more. But because we wanted to see it for the different groups, it is better to check for normal distributions in the different groups. So we would like to put university to the factor list and see whether at Dunstone University or Sussex University the data is normally distributed. Yes. Okay, so here at Dunstone University, the significance is bigger than, so it's bigger than 0.05. Normally distributed, again, numeracy is smaller than 0.05. That is not normally distributed. And we would like to see for the Sussex University, again, percentage on SPSS exam is normally distributed, while numeracy is not normally distributed. So you can only do the parametric test for the percentage on SPSS exam. Okay, so to sum up, if you would like to check whether your data is normally distributed, first you look at the shape of the histogram, whether it follows a normal curve. You can also look at the p-plot. Here your data has to follow a diagonal line, remember. Then you can also look at numbers to quantify normal distribution. Skewness and kurtosis are both have to be 0 or close to 0. And finally, you look at the Kolmogorov-Smirnov and or Shapiro-Wilk test, and they have to be bigger than 0.05. Okay, so not smaller, but bigger than 0.05. If they are smaller than 0.05, then the data is not normally distributed. And I'm sorry, this is how you report on the data. On the Kolmogorov-Smirnov test, the Kolmogorov-Smirnov test is D. So here you put the degrees of freedom in brackets. So D100, and you will see this number in the table. So P is smaller, probability is smaller than 0.05. For the numeracy scores, it's almost the same, so they were both significantly non-normal, so there is no normal distribution. Okay, that's it. Thank you.